Hello guys, welcome to my YouTube channel. Today I'll be explaining the basic classification scheme of viruses. So there are many ways of classifying viruses. Firstly, there is the basic classification scheme and there is the Baltimore classification scheme. The basic classification scheme includes the viruses are classified according to the nucleic acid they possess, whether they are negative stranded DNA viruses, double stranded DNA viruses, positive DNA viruses, retroviruses, which are positive RNA viruses, negative RNA viruses, and double stranded RNA viruses. And they are also classified according to the shape they have. Do they have a icosahedral shape or a helical shape? They also classified according to whether they have an envelope or not. Some viruses have an envelope and some they don't. And some are classified according to whether they have what type of host do they have. Do they have human hosts? Do they have animal hosts? And lastly, which is the Baltimore classification scheme, we classify them according to the way they achieve transcription. So, first one, for the basic classification, we have the type of nucleic acid they possess. Number 2, we're going to have the shape, whether they have an envelope or not. And then host, number 3, we're going to have host. And then number 4, we're going to have how they achieve transcription. You excuse me for my handwriting if you cannot see properly. So the most important one is the Baltimore classification scheme. Okay. How do we use the Baltimore classification scheme? So this is how we use the Baltimore classification scheme. We're going to see all viruses have to synthesize proteins, right? So we're going to classify them according to how they synthesize their mRNA. So everything is going to come to this. Do they achieve their RNA using host enzyme? Do they encode for their host enzyme? So that is the main purpose, the main thesis of the Baltimore classification scheme. So firstly, we're going to discuss the DNA viruses. The DNA viruses are the simplest ones. So DNA viruses, this is the one. How do they achieve transcription? DNA viruses use the host enzyme, DNA dependent RNA polymerase, to synthesize their mRNA. That's it. They use the host enzyme, DNA dependent RNA polymerase. In that way, they synthesize the mRNA. But how about this one? Before I go to these ones, I want to tell you these DNA viruses, they can use either of the strands as the templates for the synthesis of mRNA. I know that in humans there's a template strand, and that is the only one that is used to synthesize mRNA. But DNA viruses use both of the strands. We call them they synthesize in a bidirectional way. So how about these two? The negative and the positive. These ones have to first go into a double-stranded form. How do they achieve that? They use DNA-dependent DNA polymerase. That is how they achieve their double-stranded form. From there, they use the same enzyme to synthesize as double-stranded to synthesize mRNA. So we're going to move to positive double-stranded RNA viruses. How do they synthesize their mRNA? I know we used to DNA being the genomic code, but viruses also have RNA as their genetic code. So how do they achieve transcription? They are going to encode for an enzyme called RNA polymerase, RNA polymerase. Which strain are they going to use? They can use both to synthesize that, the mRNA. So now we move to negative RNA viruses. How do they achieve their transcription? They are going to use the same enzyme as that one, RNA dependent RNA polymerase. They are going to synthesize a complementary strand using this enzyme, and then that is going to be the complementary strand. Obviously is going to be positive, and this one is directly recognized as mRNA. Why? Because it has a cap and a poly A. It gets a cap and a poly A tail in the 5' end and here in the 3' end. And if you know transcription in humans, you know that this one is recognized as mRNA. So now we're going to positive RNA viruses. These ones, they are directly recognized as mRNA also. Why? Because they have the poly A tail and the cap. So they are translated to protein. So that is the mRNA. But how about subgenomic RNA? Dependent RNA polymerase is going to copy a complementary strand. The complementary strand is going to get a poly A tail and a cap, and then it's recognized as mRNA, and it can synthesize a polyprotein, a subpolyprotein, not the whole protein as this one. So this one is important. It doesn't copy this negative strand back to the positive one, but it uses this one. But this one gets a cap and a poly A tail. So I'm going to wrap up my presentation by saying DNA transcribed in the nucleus, RNA viruses transcribed in the cytoplasm. Thank you for watching. See you next time. Subscribe to my channel. Thank you.